Hello everyone, we are back. So this time we're going to talk a little bit about how the neuroevolution or evolutionary algorithm works in a high level, right? So why you call evolutionary algorithm is because they follow an approach of the kind of species evolution. And how the algorithm works, it is basically we start with a population of species, right? On our case here on the car example, it's a population of cars that would be part of a population, and you put those cars to interact with the environment, which it is our game, right? And then after some time, we compare how each item on the population performed in the environment, which we call fitness, and then we sort all the cars that performed well and choose two from the top, and we create another, let's say another generation of cars based on the two best cars that have performed with the environment. And then we do the same process again. So after you have generated another generation based on the father and the mother, which was the best to interact in the environment, we keep doing that constantly, and that's basically that's what we call evolution. It's because we chose the best species that has adapted to the environment, and therefore they were. And how to choose those that was the best, it is based on the performance. In the car example, it is those cars that went further in the road, right? So this image here try to illustrate a little bit. So basically we have evolutionary competition, which is a population of species which contains neural network as part of the species itself, and then we put this species to interact with the environment, and they will be performing actions, and the action is basically steer or turn to the right, to the left, or go forward or stop. That's the action that will be performing against the environment. And then we're gonna see how they perform, if the action was good actions or bad actions. So, and then we keep on this loop over and over again. So let's look at the car example here. So we started generation, and we are on the first generation, the second generation here, and see loads of cars, loads of stupid cars, but this one went further. So we're gonna pick up this and the second best and generate another generation of cars based on those that went well. I'm gonna show in the code to illustrate how we reproduce new species from the fathers, right? The parents that performed well here. And let's have a quick look at the code itself. How is the process? I'm gonna show how it is the evolving part, right? So we are interacting in the game, and the game is happening, and every time that the game starts, we generate a new generation of species, right? And how this generation or evolve happen? We select from the population, so we look here, that it is population. We calculate the fitness, so basically seeing those species that better performed on the environment. And after calculating the fitness for each in the species, you can kind of look at here, we see that we're gonna go through all the population, and we calculate the fitness, and we sort by fitness, and you get the best, right? And then we return the two from the top, which we call mom and dad, and then we apply the reproduction between the two, the mom and dad, the best, the interacting in the environment. And let's see how is the reproduction happen. Basically, we get the whole population and check if it is not the mom and dad, so we're gonna do the same. And you get the genomes from those, that what I said, we have the genome on the item, right? So on the card itself. And then we apply the crossover strategy, basically mixing up the genes or the DNA or genome of both genomes. And let's see how the crossover kind of works. It is basically, we get a genome, it is basically a new neural network, I think, and we create an offspring from the parent. So in this case, we're gonna taking from, let's remember that. oh, you call genetics here. So nom is genetic. We took from the one that we passed in here. In this case was the dad, right? Genetically what is passed is the dad. And we are using the mom to cross over with the dad. And when we pass here, and you keep mixing weights from both. Sometimes we take from the dad, sometimes we take from the mom, which is this. This is mom, and this is dad. Let's even rename that to make it clear. And then that's the dad. And you see, so we use the dad, and this it is the mom. And you do this crossover, and we have offspring. And you basically are changing the weights of the layers. Right, so you need to understand a little bit about how the neural network works. That's why I recommend you to check out my other course about neural network. So then you're gonna understand better those concepts. But we are gonna talk a little bit about neural network and weights and bias. But basically it's just that in a high level, we just cross over the layers weights from the two best performers that interacting in the environment. Let's see, this is the reproduction. And after the reproduction, we do the crossover, and we do a small mutation following a rate. So the mutation, what the mutation means, it is that we change a little bit the value of our, actually here, we change the value a little bit of the to make it a bit different. So what it is, neuroevolution or genetic algorithms or evolutionary algorithms, it is basically that. It is these three steps. It is selecting from a population, do the reproduction, and using crossover strategy, and applying a mutation on top of that. And that's it. It is all about the neuroevolutionary algorithms. And why it makes neuro, it is because we are applying those techniques on neural networks, and that you're gonna look a little bit later in this course. And that's it, right? So that's what it is, the process of evolving, or the process of neuroevolution. And that's the whole concept that you have.